Hello, welcome to m253 Calculus 3 at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will take a quick look at line integrals. This is going to be our first set of integrals that we're going to study, and this will begin our calculus of vectors and vector fields. The first type of integral we're going to take a look at is sometimes known as a path integral, but it's essentially a line integral where we integrate over a particular curve, and what we're integrating is an actual scalar function. And by scalar function, it would just be a function of 2 or 3 variables. One can take a look at this geometrically as a curve that you're partitioning, and as you partition the curve, you take a sample point within the partition and you evaluate it at that particular function, the particular scalar function. And so in doing so, you can imagine that this could give you, by evaluating the particular function at a sample point, it could give you a particular height maybe, and so you can find the area of that. And then you can imagine that this might be something like finding the area of a fence where the curve is like the path of the fence on the ground. But we will also take a look at some more applications in the later part of this section. The main formula that comes out of this, we say that it's an integral over curve C of some scalar function f ds. Now f will be, that's the kind of like the notation, but the working definition is that you have to parameterize the curve C, and then you put that parameterization r of t into the function f. And so that's the f part. And then the ds, if you remember, was a notation that we used for arc length. And the arc length was, in finding the arc length, we found the magnitude of the derivative of the parameterized function. So we have a notation sort of definition, and that's the integral over c of f ds. And then we have the working definition where we actually parameterize the curve c, and then we use that parameterization as part of the integral. Now another integral we're going to take a look at is called a regular line integral. And a line integral is generally an integral where we integrate a vector field over a curve. One can imagine the geometry with this as a dot product between the vector field and dr. And if we take a look at the parameterization of the curve C as r, then our definition turns into a working definition where we integrate the vector field, and for each point on the curve r of t, we're going to put that into the vector field, and then we're going to dot it with the r prime of t, the tangent vector. And then if you remember the dot product of two vectors, one application of that would be work, and so we'll see that application in this section as well. Speaking of applications, the applications that we were just mentioning were finding the area of a fence, but in a path integral we can also take a look at the mass of a one-dimensional object through a two-dimensional plane or a three-dimensional space. And so if the scalar function describes something like a density, and then the wire is given as a particular curve, and we can parameterize that, then we can find the total mass of the curve by doing the density times the length, and doing that in pieces will turn it into an integral, and the integral over a scalar function, the line integral over a scalar function, is what we would be computing. The other part, the other line integral where we're integrating over a vector field, kind of gives us the idea of work. If you remember, the dot product between two vectors gives work, and we could take a look at the work going around from one point to another point, or a particular path, a circular path, or in this case a rectangular path. We can find the amount work needed to go through this path while we're under the influence of a vector field. The other application we're going to take a look at is kind of a glimpse of one of the big theorems that we're going to study, and that is a flux. So instead of looking at how the vector field reacts to the tangent, to the curve as we're going along the curve, we can take a look at how the vector field reacts to the perpendicular of the curve, to the normal vector of a curve. And that is called a flux. So we can imagine the flux of the vector field going through a particular curve. And so instead of dotting it with the tangent vector, we're going to dot it with the normal vector. So the idea of the unit tangent and unit normal becomes important for us when we begin computing these integrals. Okay, so that is our quick overview of line integrals in section 6.2. Good luck in this section.